Hi guys, welcome to my first YouTube lesson. I've been looking at your past papers. I've just decided that the first lesson is gonna be on the number patterns. So yeah, I've noticed that there's quite a lot of marks on those questions. So it's quite important that one knows how to answer the questions in the examination. I thought maybe I should start with a quick recap of the number patterns that you will have learned up until this point, and then from there we can then look into attempting some of the past exam questions. If you remember, so there are three types of number patterns. There are three types of number patterns that you can get asked in an exam, right? So we know that there's arithmetic sequence, and then so also in grade 11 you were introduced to quadratic sequence. And then there's also a geometric sequence, which was introduced in grade 12. So yeah, essentially these are three types of sequence that you can be asked in the examination. So yeah, on the arithmetic sequence, so we know that arithmetic sequence, it's a sequence that if you take the difference of any consecutive terms, like you get the constant difference, right? So that's how you are able to differentiate, if a sequence that you're given is arithmetic or not. So just to show you an example of what I'm talking about. So if you have, let's say, just give me a second. Yeah, so let's say you have a sequence like, let's say you have 3, you have say 7, you have 11, 15, right? So this sequence, so if we take the difference between these consecutive terms, so if I take 7 minus 3, I get 4. I take this minus, I get 4. I get 4, right? So yeah, because of like the difference between consecutive term gives you a constant difference or a constant, then like this sequence is called arithmetic sequence. So that's how you are able to distinguish if it's arithmetic or not. Okay, so let's move on to, I'm just going to quickly jump quadratic and go to geometry and then come back to quadratic sequence. So how do you tell if a sequence is geometric or not? So for geometric, if you remember, we're able to tell because of what? Because if you take the ratio of consecutive terms, then you expect to, you should get the constant constant number, right, across. So in other words, you should get a common ratio as they usually refer to it. So if I show you example, so let's say we have we have a sequence where, let's say, start at 3, and then it's 6, and then it's 12, and then it's 24, right? So if you take the ratio of consecutive terms in this sequence, so you're gonna get 6 divided by 3, and then 12 divided by 6, and then 24 divided by 12, right? So so you can tell that you can see that this gives you 2, this gives you 2, this gives you 2, right? So just because this sequence gives you a constant ratio, then that tells you that the sequence in this particular case, it's a geometric sequence. Please be careful between these two. So this one, you take the differences. So if the differences, they give you constant, it's a arithmetic sequence. And then for geometric, we take the ratio. If the ratio is constant between consecutive terms, then that's a geometric sequence, right? So for quadratic, so quadratic is quite, sorry, let's see this. Yeah, okay. No. Okay. Anyway, sorry. Okay, I'll just write it down. Yeah, so for quadratic, yeah, so for quadratic, this sequence, I mean, they love it very much. If you look in almost all the past papers, you will see that it's always asked, right? So yeah, for quadratic sequence, so let me try to explain this. So for quadratic sequence, so you're able to tell if a sequence is quadratic or not if like the second difference of the first sequence, I mean, of the first different sequence is constant, right? So essentially, you have this original sequence, and then you take the differences that form a new sequence. Then the differences of that new sequence, if they give you a constant, then that's a quadratic. Right? So let's look at examples so that we are both on the same page. So if you have, so let's say you have 5, right? And then let's say we have 9, and then let's say we have 15, and then let's say we have 23. Right? Yeah. So if you take the difference, so if we take the difference of this sequence, so this gives you 4, this gives you 6, this gives you 8, right? So this is let me just, so this 4, 6, 8, this is the first difference that I'm talking about, right? So the first difference which form the sequence. So now we need to find the difference of this, the first sequence. So this gives you 2, this gives you 2. So because of like the second difference of like this sequence, it gives you constant, then that's how you are able to see if a sequence is quadratic or not, essentially. Okay, yeah, I hope that is clear. And yeah, if you still don't understand, please feel free to pop me a question or comment. Then I will try to explain it a little bit better or share some example with you. Right? Yeah, that's essentially how you're able to differentiate between those 3 types of sequence that you can get in exam. So now I want us to look at the general term, right? So the general term is usually, yeah, it's a formula that is used it's a formula that you use to determine the value of a particular term in a sequence if you know the position of that sequence, I mean, of that term, right? So you usually see it noted as Tn. So yeah, the question in exam can come and say determine Tn or determine the nth term or the general term. So all they mean the same thing, right? So let's write down. So this gives us so the value of a term in a sequence if we know the position, right? If we know position. sorry for like a bad handwriting. So essentially what I mean is that if we have this formula for a given sequence, then we're able to determine the value of any term if we know the position. So the position is what's notated as n. That n there is like term number. So what's the term number, right? Okay. So so for both those sequences that we've discussed, so let's write down the general term for each, right? So for arithmetic sequence, so, and then we have geometric, and then we have a quadratic sequence. So yeah, so for what do you call it? Yeah, so for arithmetic sequence, so the general term that's noted as Tn equals to A plus n minus 1 D. Yeah, don't worry about the parameters there. I will just come back to them now and just remind you of what each means, right? And then for geometric, so we have Tn equals to A R n minus 1. So this is R. Okay, so yeah, that's R. Yeah, now it looks much better. Okay, so then for quadratic sequence, so for quadratic sequence, so Tn is given by A n squared plus Bn plus C, right? So yeah, for each of these, right, for each of these general term, for us to be able to have an exact formula that will allow us to determine the value of the value of the terms. So we need to know the value for A and D, right? So A, this is the first term, is the value of the first term in your arithmetic sequence, right? So essentially, so if our sequence was 2, 4, 6, 8, right? So A in this case will be what? A, it will be 2, which is the first term, right? So it's always the first term in your sequence. And then D, so D, this is the common difference that we talked about, right? The common difference between those consecutive terms. That's what this D, the constant D is, right? So in this case, you have, yeah, so this is 2, 2, 2. So which means then D is also going to be 2, right? D is also going to be 2. So once you know A and D, then now you can substitute them, and then now you have your general term formula for arithmetic sequence. So n in this case, so n is just like, yeah, it will be what you substitute as a variable. So if, like, let's say you want a term number, yeah, let's say term number 3 in this sequence. So which means you will then say T3 equals to, what's A? A is 2. And then you say plus, what's N? N is 3 minus 1. And then multiply by what's D2, remember? So now you have what? You have, remember BODMAS, so we have 3 minus 1, which is 2. 2 times 2, that's 4, plus 2, plus 6. Bingo. So that gives us like that boy there. Right. So yeah, that's for arithmetic sequence. So for geometric, how do we determine the parameters for a geometric sequence. I mean to say like the geometric sequence general term formula. So yeah, so for okay, let me just write it up there. Let me write it up here. Okay, let's write it here so that is clear at the top. So yeah, so A again, A for geometric. So this is it's like the first term in your sequence, right? So let's make it this clear, right? So for arithmetic and geometric, A is always the first term on your sequence. And then D on arithmetic is the constant difference. Whereas like R in this case for geometric, R is the common ratio on your sequence, right? So let's show example. So remember our sequence that we had was 3, 6, 12, 24, right? So in this case, A will be 3, right? So remember we said A is the first term in your sequence. And then R will be the ratio between the consecutive term, which is that constant ratio. So that will be 6 over 3, which is 2, obviously 12 divided by 6 is also 2. So yeah, you can see like that's your R. So that's what you substitute there. So yeah, once you know A and R, then you know your general term formula for geometric sequence, right? For your geometric sequence. Bingo. So essentially you can test this out. You can test this out. How do you test it out? So you can say, okay, let's say you are looking for a T4, right? Which is term number 4. So we're gonna substitute T4 in our formula. So it's gonna be 3 and then 2. What's gonna be N? N is gonna be 4. So 4 minus 1, right? So that gives us 3 terms. 2 to the power of what? 4 minus 1, that's 3. So essentially 3 to the power of 2 to the power of 3. Yeah, that's like 2 times 2 times 2, which is 8. And then you have 3 times 8, right? So that gives you 24. Look at that. Isn't that amazing? Yeah, so essentially when you have that guy, you can be able to determine those terms, any term in the sequence, right? You can also expand this sequence using that general formula. Okay, so now let's look at for quadratic. I'm just going to raise my board. Okay, maybe let me open the new, okay. So for quadratic, remember we had the general term formula as an squared plus bn plus c, right? So yeah, for quadratic, so for us to be able to calculate, the general term formula, we need to know the value for what? We need to know the value for A, value for B, and the value for C, right? Then how do we determine those? I just have to say something that's important here. So please don't make a mistake of don't make a mistake of assuming that A in a quadratic sequence is the first term in your sequence. No, that's not true. So it's only first term in your sequence for for geometric and arithmetic sequence. Okay, so there are 3 equations that we need to solve for us to be able to determine, the value for A, B, and C, right? So the formula, I'm gonna write the formulas down, and then now we're gonna apply them to, remember the sequence that I shared with you, right, at the start. So the formula for us to get A, so we have to let or solve the following. Solve the following. Following equations, right? So the first equation is 2A. I'm just going to say 1, which is the first equation essentially, mass equals to second difference. Remember that second difference in your sequence where I said, like, we take the first difference, and then once you get the first difference, it forms a new sequence. And then that new sequence, like, we take a difference, then, like, you know, that second difference value, we're going to equate it to 2a, right? 2a is going to be equated like that, forms equation 1, right? Equation 1. And then equation number 2 is going to be 3a plus b must equals to the first term in what? The first term in your first difference sequence. Okay, yeah, don't worry too much if you are getting confused. We're gonna show example of what I mean. So, but I mean the first term in your first difference sequence, not on the original sequence, on the first difference sequence. And then the last equation that you need to solve is A plus B plus C must equals to the first term in your sequence. Yeah, this is your original sequence, right? So essentially how this A plus B plus, how A plus B plus C came about. So this is when you substitute. Remember, if you substitute on the general term formula here, right? If you substitute T1, which is the first term, T1, which is the first term, right? So if you substitute T1 there, so you see that you're going to have A 1 squared plus B times 1 plus C. So essentially, when I have A plus B plus C, so mass equals to what? The T1, which is the first term. That's how we got to this third equation, right? So now let's look at the example of the sequence that we discussed previously, and then let's try to solve this three equation and then determine our general term, right? Okay, so yeah, so remember the sequence that I gave you. It was we had 5, we had 9, then we had it was 11. So let me think. No, it was 50, and then 23. That was the quadratic sequence example that I gave, right? So with this example, so if we take the difference, then that gives us 4, 6, 8. So this is original sequence, right? The original sequence. And then this is the first difference, sequence. And then now we need to find the second difference, which is 2, 2. So I just want to draw a link here so that you understand what I was referring to in the previous page, right? So remember what I said. I said we equate the 2a to second difference. So second difference in this case is what? Is 2a, right? So is 2. So which means we're going to equate 2a to 2. Then we're going to solve equation 1 in our previous page, right? So that equation 1 that tells us that this implies that a equals to 1. Look at that. Okay, and then now, so we need to solve for b, right? For b. Remember, we're trying to solve for Tn equals to an squared plus bn plus c. That's what we're trying to solve for. So far, we managed to get a, right, which is 1. So now, how do we going to get b? How are we going to get this b? So let's go back. So we said, let 3a plus b equals to the first term of the first difference, not on the first sequence, of the first difference of your sequence. So this is the first term. This is the first term of the first difference sequence. So then this means that Now we need to solve the equation. Let's use another pen. So we need to solve for 3a plus b must equals to 4, right? This is the second equation. Remember, we already solved for what? For a. We know what a is. So if we substitute a there, then we only left with b to solve for. So it's going to be 3, 1 plus b equals to 4, right? So yeah, if we do the maths here, so essentially it's going to be 3 plus b equals to 4. So if you take 3 to the other side, then you're going to have, so this implies that b equals to 1, essentially. Because yeah, it's going to be 4 minus 3 equals to b. Then that means like, 4a equals to, b equals to 1. So now we have b as well. So the only thing that we're left with is what? Is to solve for c. So how are we going to get c? Let's go back. So we said c, to get to like c, to solve for c. So we need to equate this equation to what? To the first term in a sequence, right? First term in a sequence. So if we do that, so we're going to have, what's the first term in a sequence? Like that's 5. So we're going to have 5 equals to, what is the thing? So a was 1, right? And then what is b? B was 1 as well, and then plus c. So this is us substituting the values on this equation, right? On this equation, like a plus b plus c equals to the first term. That's what we are doing there. That's what we are doing here. So so this is 5. So if we calculate this, so this is 1 plus 1 is 2 plus c. So we have 2 plus c equals to 5, right? So now we need to solve what? We need to solve for c. So we take 2 to the other side, then we have c equals to 3. So now we have solved for what? We have solved for our general term formula there, right? So then now we can just substitute it. So that's gonna be, that's equals to, what's a? A is 1, so that's gonna be n squared, because it's 1 times n squared plus, and then b is 1, remember, so that's n, and then c is equals to 3, then that's 3. And that's the general term formula. That's the general term formula, for our quadratic sequence. So if you want to test it out, we can. So let's try to solve for what? Let's try to solve for this guy using our new general term formula that we just derived, right? So which means this is term number 4, right? So we need to substitute T4 in the formula. So we can go and say, okay, so T4, that's going to equals to, what's going to be? It's going to be 4 squared, right? Remember, we're substituting n as 4. And then plus, so what's going to be n? N is 4 again, plus 3, right? So what is 4 squared? Sorry. Okay, sorry, let me just open a new page. I'm running out of space. Okay, so we have Tn. That's right. Tn equals to n squared plus n plus 3, right? So we said we are looking T4. T4 is equals to 4 squared plus 4 plus 3. So that's equals to 16 plus 4 plus 3, right? So what is 16? What is 16 plus? Yeah, what is 16 plus 7? 16 plus 7. So 16 plus 7, so that is 23. Isn't that amazing? Look, 23 and then 23. Okay. Yeah, okay, thanks guys. I think I'm gonna leave it here. So, but yeah, I hope at the end of this video, you will now be able to understand the difference between the 3 sequences that you can get asked, and you can be able to derive the general term formula. So yeah, in the next video, I'm gonna I'm gonna be sharing with you the how to determine the sum of n terms, and then from there we're gonna dive into the past papers, and then just do 3 questions, and then just show you how we apply this stuff, and hopefully by the end of that you feel confident about these questions and realize that there's nothing really complicated. Thank you, guys. Thank you. And please don't forget to like and subscribe. And if there's anything that you want to see that I'm not covering yet, please let me know. Because I'm really doing these videos to just help you guys to prepare well for your upcoming exams. And I hope you find these videos very useful. Thank you.